Hi there, my name is Eric Ma, and I am a rising senior in high school. In addition, I am also a dedicated member within the First Tech Challenge or FTC community. Through year after year of participation within the program, I have seen firsthand the caveats and annoyances with drawer slide designs on the current market. In response to this, I took the initiative in designing my own and significantly improved version of drawer slides, as you can see in front of me right now. So without further ado, let's dive in to see all the hidden features of this intricate innovation. And here it is. Looks pretty normal, right? It even slides like a normal slider. The only real difference that is noticeable are there are extra nuts and screws on the ends. But in reality, it's a brand new concept in the world of drawer sliders, featuring an abundance of innovative elements and design choices that make it easily stand out from the rest. To begin, the biggest issue plaguing drawer slider designs is that of wobbling. The biggest reason for this is primarily because ball bearings are concentrated towards the middle, allowing room for the ends to teeter-totter. This is very bad for performance. With my design, we maintain 3 sets of ball bearings all throughout the drawer slider, with the start, middle, and end, coupled with differently invented fasteners, allowing the top set of bearings to roll in place while the middle and bottom travel freely when extending the slide. With these bearings distributed all throughout the slider, we can easily eliminate any chance of wobbling in our product. Now I'd like to draw your attention back to these fasteners up here. These innovative and custom screws, which I call T-screws, serve many purposes. Again, they fasten the top set of bearings, but as you can see, they are also mirrored on the other side as well. This is because they also serve the purpose of allowing users to mount attachments. As part of my drawer slider product, we have the pulley module attachment, which can sit onto these screws. This allows our pulleys to string and power entire slide stacks to effectively mount within the thickness of a slide, allowing for very compact and effective stacking, which you can see here. Additionally, with the use of these mounting sites, users can then customize their own attachments and mount freely on all 4 of these and with attachments they see fit. And with 2 pulley modules mounted, it should look something like this. And now let's assemble the slide stack. It's a very simple process, just as you would expect, with 1 screw in the back. And there you have it, the slide stack you saw previously. The advantages to this design should be pretty clear now, but to reiterate, with these pulley modules, the slides can now stack back to back, which allows for normal sliding as expected, but it also provides a lot of extra stability as the slides are directly on top of each other. Additionally, it is also extremely compact now, meaning it saves space drastically for other subsystems. If we measure right here, you can see just how thick it is for a stack of 3 slides. So here, I'll briefly demonstrate how to mount this onto a channel. It's roughly the same as doing it one at a time, except the only difference being that there's a through hole that goes through all of the slides at the same time. And voila, here you go. The opposite is just as easy. The opposite meaning disassembly. With traditional slides, you have to take the first one off, then the second one, all the way until you reach the one you need to replace. However, with my through-hole design, you are able to lift the entire stack off, directly getting to the slider you need to replace, making the overall process for maintenance and whatnot much easier. So now I've quickly strung these slides up just to demonstrate how they function. If I pull this string here, it goes up, and then it comes down when I release, as any normal slider would. A few things to note about the pulley modules that I designed. Right now it is continuously rigged, but there are holes on each individual pulley module that allow for cascade rigging if that is preferable. Additionally, each of the pulleys is held on with a set screw, making it really easy for users to replace pulleys and strings if necessary. And one more thing, these pulley modules have even more uses outside of just mounting them on your slides. You can put these on your channels or wherever else on your robot, that way redirecting the direction of your string. If you want it to come down around, if you want it to turn 90 degrees or anything else, you can mount them anywhere you want to help you guide your string. All in all, I hope I've made clear the advantages to this drawer sled design. And with that said, I'm excited to see the creative ways that you students and teams make use of these slides for. I'll see you on the field.